All right, welcome back everyone to the HeadStarter Accelerator project series. In this episode slash video, I'm going over the HeadStarter financial analysis and automation of LLMs project. Without further ado, let's get started. Just a quick overview of the code. Gonna explain things a bit fast. I hope you don't mind that. So, if you're not aware of what we did last time, I highly recommend that you watch the previous video as a lot of these imports are repeated. Now, first off, we install our libraries. We're going to install Y Finance, which is a Yahoo Finance, Exchange Pinecone, OpenAI, Python.env for environment variables, local community, LangChain community, and sentence transformers. I'm going to explain why we need, well, Yahoo Finance is going to help us extract financial data and financial data from the web about these companies that we are looking into. We are using NumPy, um, and we are using cosine similarity as science transformers and hugging face embeddings like last time. Now we're going to get this stock info. We have this function here, which is gonna seek stock info, in which we can pass a symbol. The ticker essentially just means, you know how in the stock market or whatever market you want to reference, MST or Misfits, MSFT or MST stands for Microsoft. That's essentially what ticker is, and it's the representation of the stock name for each individual company on the stock market. So we're gonna get the data based on the ticker, based on the symbol we pass through, as the function says, etc., etc. Then the properties of said stock info is going to be symbol, and the second argument of the get method is going to be the default argument. So it's like a knowledge correlation, or however you want to reference it. So ticker is going to be stockinfo.get symbol. Name is going to be stockinfo.get log name. Business summary is going to be stockinfo.get long business summary, and etc. etc. Moving on. From that, we're initializing data with, and we are looking for the NVIDIA ticker and stock info, etc., etc. And the address, website, industry key, sector key, and a bunch of other information. Now, we are going to initialize the Hugging Face embeddings function and the causing similarity function um, from before. Last video, I went over this. So let me just read the function description slash docstrings of each of them. If you don't know what docstrings is, essentially these are the things that generate the descriptions for each function. You see how they are similar? That's what a docstring does. If you have IntelliSense or within your programming language, you are able to see it if you hover over whatever you're defining, etc., etc. So generates embeddings for the given text using a specified Hugging Face model. We are using sentence transformers or MPNet base v2 again this time. And then cosine similarity calculates the cosine similarity between two sentences. Similarity between two sentences is what I want you to focus on, not the cosine similarity bit. It explains former explains the latter type situation. Moving on, we're going to get the stock info of ABL, which is ABL is the ticker for Apple. Then we're going to get the description, just a summary. To access the description, we use this method of accessing properties within a dict, can company description, etc., etc. I also find the companies that make smartphones and are headquartered in California. Based on the cosine similarity in company description, you find whether or not if a company meets or fits that description. Smartphones get quoted in California, 36%, 33, 36.35% similarity. Get all the stocks in the stock market. We initialize the get company tickers, downloads and parse the stock ticker symbols from GitHub hosted SEC company tickers JSON file to return a dictionary containing company tickers and related information. The data is sourced from the official SEC website via a GitHub repository. Okay, sorry if you heard that, but if response status says okay, JSON loads, decode, ECF8, with open JSON, the downloaded JSON as file, JSON dump company tickers file, company tickers. Then we're going to go into the Pinecone website to create our index, the specific project, get the heading face embeddings, then we're going to initialize the first argument index name to be index name embedding equals HF embeddings. We're initializing a vector store for the Python vector store. And this is sequential processing. Think of it as I know some of you are familiar with um or have taken like AP Computer Science A, B, or principles. Um, you should be familiar with what sequential processing is, and later on you should have learned what a greedy algorithm is and or what a greedy approach into determining which process would which process you should take and which process you shouldn't take. You should have learned a more advanced version of the aforementioned in, I believe, computer architecture. So we are going to process the ticker for Apple and wait API request and response. Then we're going to store the data and process Google, then Microsoft, then Tesla. We couldn't get Tesla, um, but that's fine. Documents, document page, content, start description. So on every single company tickers which we initialize slash downloaded, the items, index and stock, ticker, stock, add ticker, then stock data get stock info, stock ticker, etc. is going to return that um, JSON objects and or objects back to you. Then add stock data, add business summary, stock description. Then we're going to import all of this data into the Python vector store embeddings from documents, and we initialize documents to take and paste content, stock description, and metadata to be stock data. If you're not familiar, so essentially is for stored every single stored value data will have a metadata attached to it. Then for the embeddings, we have plug and paste embeddings, then index name, namespace, etc., etc. Now let me go over parallelizing. So parallelism. So we have a stock list of the stocks slash checkers we want to extract data from. Then you have a main controller with 5 parallel workers. Think of workers as robots that work for you. Um, I'm not going to mention what else they're called. But simultaneously, so you're gonna run them in bulk. Then worker one is going to process each worker is going to process a specific ticker that we assign them to. And they're going to get and store the data. Then going to check the status, and if it's successful, we process the next batch. Initialize a tracking list, unsuccessful tickers, successful tickers. We we only want the successful ones so we can further process them for later. Which honestly, if you really do care about your stock portfolio that much, then you would get to the bottom of every single error and try to resolve it, and or would directly manipulate the data that you downloaded. Found not found error, etc., etc. Then excessive trigger, a strip for line, and F and line dot strip. Then we're going to process the stock ticker, get the data, stock, start back. But we're not using that. And we're going to run parallel processes with concurrent features, jet flow executor. Max workers equals max workers as executor, future jet ticker equals executor submit pass. So stock ticker. So this will take the function, this will take the arguments. Yeah, it takes in cards for ticker and tickers. Yeah, okay. For feature and concurrent features has completed. Feature to ticker. Ticker equals feature to ticker at feature. Then let me just move past these. Already processed, already processed, already processed. Successfully, etc., etc. Then we're going to perform RAG. retrieval augmented generation on the data that we just stored from the vector store. Now with the now with the Python API slash client, our query is what are some companies that manufacture consumer hardware? The keyword would be hardware, manufacturer, and consumer. Raw query embedding, initialize it having face embeddings in a query. Then from raw query, initialize our Python from we already initialize our Python index and we're going to query it. The vector is going to be query embeddings, raw query embeddings to list top K10, so the top 10. Include metadata true, namespace, top matches, and you get a list of data back. Context, metadata text for item, and top matches. Then we are going to do some prompt engineering. Okay, then we're going to use the Grok API, and we're going to use the OpenAI v1. We're going to initialize the sensitive prompt and OpenAI v1, which is just general, but we're going to initialize the system prompt, and we're going to use Llama 3.170b, versatile. Then we're going to ask the LLM based on the process content, the prompt engineering that we just constructed. Then, based on the context provided, name some companies that manufacture consumer hardware include Advanced Micros Devices, AMD, Nvidia, Applied Materials, Texas Instruments. Additionally, some other companies, Honeywell, Broadcom, Inc., Lowe's Company, Walmart. Not all these companies manufacture consumer hardware directly, but they are involved. So I really like this because I I admit that I do have a trading bot. I have a trading bot, but I haven't been running it recently because it has some errors. So I gotta fix it over break. Stay tuned for that. I'll be making a video on the trading bot as well. But I'm pretty sure this ends the video. But yeah, I'll be posting this on LinkedIn and my other socials. I'm starting to post more on my socials now. I'm trying to find a workflow for blog posting, but all the blog APIs, I only found one successful blog API which remotely allowed me to do what I wanted. Other than that, I had to do some insane prompt engineering to actually automate like blog posting, like multi-platform blog posting, which is nuts. Like you think they'd have like their APIs up and running for developers because developers are too lazy to write multiple times in different formats, and I'm developers in question. But I really don't want to write multiple times in different formats because that's really arduous, to say the least. And if making a Robinhood bot wasn't a telltale sign that I do not like wasting time on mundane things, then I don't know what to tell you, buddy. If it takes me longer than like 3 hours to do, I'm probably gonna automate it. And the expected results take years of consistency, then I'm definitely going to automate it if feasible. But yeah, that's my little rant after the end of the overview, general overview of my week 6 of the HeadStarter Accelerator um residency. Stay tuned for week 7, which I likely will be posting on Friday. Thank you for watching.